Hello, Math 006. Welcome to the first section of our last unit for this course. And we are going into 10.1, which is radical expressions, functions, and models. If you are tired of factoring and working with problems of that nature, then the good news is we're taking a sidestep and doing something, I don't want to say completely different, but not very similar. If you really liked factoring, hopefully you really like this stuff just as well. So what we're talking about is square roots. And you can see from the definition here, the number c is a square root of a if c squared equals a. Now what that means is if you square something and you're getting a number, that's going to be its square root. So just looking at some ideas. And this idea you're probably very, very familiar with, but I just want to walk through the very basic problems just so we can see how that's going to build up into these more complex looking problems. So the first one, find the square roots, keep in mind this is plural, find the square roots of the following numbers. And the first one we're looking at 4. So we need to think, okay, which number or numbers can we square and get a value that's equal to 4? Well, we know that we could square a 2 and get a 4, but also we could square a negative 2. So 2 and negative 2 would be the square roots of 4. The next one, 81. Again, we want to think, okay, which number squared equals 81? Well, we know 9 times 9 is 81, but also negative 9 times negative 9 equals 81. So again, 2 square roots there. And last but not least, 36. We want to think, okay, which number squared gives us a 36? And you're right, 6 and negative 6 are the square roots. However, with a lot of the stuff we're looking at, we're only going to be looking at the positive values. Now, how do you know when to use the negative and the positive or just the positive? And that's going to be whenever we see the square root symbol. Whenever the problem gives us the square root symbol, we're going to assume to only use the positive. That's going to be called what we call the principal root of a number. So we always would just look at that, like it has underlined here, the positive square root of 4, we would just go with 2. So if you see the square root sign given to you, you only want to use the positive value. If it's asking you for the square roots of a number like we just did, that's when you want to use the positive and the negative. Okay, so let's go ahead and start simplifying these. So we want to simplify, what is the square root of 16? Again, we can think of this just like we did in the first 3 examples. We want to think, okay, well, what number squared is going to give me a 16? Now again, we're only looking for the positive. So what number squared? That would be a 4. The next one, a negative 100. Don't worry about this negative on the outside, just bring that down with us. Okay, we still want to know what number squared gives us a 100. And that would be if we were to cover up, let's say if we, just going to use this die here, if we were to cover up that negative, you would say, okay, what squared gives us 100? That would be 10. And then we just bring that negative down with us. So this would be a negative 10 would be our answer for that. But see, the next one, we want to know, okay, what number can we square that's going to give us a negative 49? And we want to think, well, 7 times 7 is not going to work. Negative 7 and negative 7. You'd have to have a negative 7 and a positive 7, which wouldn't work because it's not squared. So we say this one cannot be simplified. And then the last one we have here is 4/9. So we want to think, okay, now we're going to have a fraction here. What fraction can we square that's going to give us 4/9? Well, we need to think of numerator and denominator separately. Which numerator can we square to get 4? That would be 2. What can we square to get a 9? Which would be 3. So 2/3 would be the square root of 4/9. So be careful. So really look at numbers 5 and 6. You really want to pay attention to where that negative sign is. If the negative is under the square root, it cannot be simplified. If it's on the outside of the square root, you just carry it and bring it down with your answer. Okay, the next idea is looking at 2 important vocab words, the radicand and the index. The radicand is going to be the A. It's the number underneath the radical. The index is going to be the little number that we see on the outside of the square root. Anytime we don't see an index written, we understand it to be 2, just like in the previous problems that we looked at. They were all the square root. So when we look at these, first thing we want to do is identify all the vocab words here. So again, the radicand is the number under the square root. So in number 8, the radicand is going to be 7. Now the index of this one, since there's no number there, and again, we're looking as far as where we're looking at for the index, we want to look right in that area here is going to be the index. If there's nothing there, we understand it to be a 2, like we said. So the index for this one is going to be 2. Number 9, the radicand is going to be a 2, and the index is going to be a 3. That 5 out front is just going to be its coefficient. We're not going to be worried about that right now. Number 10, be very careful. What I'd recommend you to pause the video, see if you can identify the radicand and the index. Okay, now looking at this one, we see that the radicand here underneath the square root is only the x. That plus 9 is not in the square root, so be very careful. The index here is 4. Okay, moving along to the next page. What we're going to do now is find the exact values for each function if it exists. So what we're going to be doing is very similar to how we've evaluated functions before. This isn't anything new here. We're going to take this value of 3 and the value of 1 in 2 separate times and substitute it in for our value of x in the problem. So the first one, we want to find f of 3. So I'm just going to set this up. So we want to find the square root of 5 times 3. And then we want to subtract a 10 from that. So we're just going to be evaluating the right-hand side. 15 minus 10 would be the square root of 5. And it's asking for exact values, so we're going to leave it like that because 5 is not the perfect square of anything. Nothing times itself will give us a 5. Now looking at the 1, we want to substitute a 1 in for x. So 5 times 1 minus 10. This is leaving us with the square root of 5 minus 10, which is the square root of negative 5, which this does not exist. So what that means is if we were to graph this function right here, there would not be any part of the graph that crosses the x value of 1. It doesn't exist. Okay, the next one, we're doing the same idea here. Again, we're talking about the exact value, meaning no decimals, of the function if it exists. If it exists, so again, this is the function we were looking at. What I want you to do, I want you to pause the video and work through 13 and 14. Be very careful with the parentheses and negatives and squaring things. So like I said, pause the video, work through it, and then check with me when you're done. Okay, so in the first one, we're taking the value of 5 and substituting in for x. So 2 times 5 squared minus 1. 5 squared is 25. 2 times 25 is 50 minus 1. Square root of 49 is 7. And again, we only want to use the positive value. Keep in mind when you're evaluating underneath the square root, at this first step here, you always work with the exponents before you multiply things. So don't take 2 times 5 and then square it. The next one, we have to substitute in a negative 1. Make sure you use parentheses because you're squaring that negative 1. Negative 1 times negative 1 is a positive 1. And you work through it, the square root of 1 is equal to a 1. Now, how you can check this, and just how similar to how we did it before break in class, if you type this expression here, the square root of 2x squared minus 1, into the graph, so like y1 equals, and then you graph this, then you hit the trace button, and if you hit 5, enter, you'll see a 7. Then negative 1, enter, you get a 1. Again, type this into y1, press graph, then press trace, 5, enter, negative 1, enter. And you can check those values there. Okay, the next idea we're looking at is we want to think about this. F of x equals the square root of x squared. We want to find f of 8 and negative 8 because we want to see if those two things are equal to each other. We want to know if we take the square root of something squared, are you always getting that value back? So let's see. So we want to start with we want to find f of 8 if we have the square root of 8. Actually, let me do this in red. We want to take the square root of 8, just to keep it consistent, squared. Well, we know 8 squared would be 64. The square root of 64 is 8. So in this case, it does work. We substitute in an 8, we get out an 8. So we know that that one is true as far as that goes. Now let's look at the next one. Let's evaluate f of negative 8. Let's see what we get when we substitute this in. So now we have to substitute in a negative 8 and we want to square it. Well, we know negative 8 squared, negative 8 times a negative 8 is a positive 64, which leaves us with a positive 8. So we can see that we still get an 8, however, this one here is a negative, and the one that we found down here is a positive. So what we have to do, let's keep reading here, because the square root of 8 squared and the square root of negative 8 squared both equal 8, the correct statement would be this. So we'd have to put absolute value bars around that A in order for it to be correct. Meaning it doesn't matter if you substitute in negative or positive, you're always going to get that positive one back. So if we were to simplify something like 15 and 16 here, we have to use some absolute value bars to make it a correct statement. And while you want to work through these is think about, could you substitute in a negative or positive number and get the same thing? So looking at this first one here, we look at 4x squared. Well, we know the square root of 4 is 2, so we can start with a 2. Now, the square root of x squared is going to be an x. However, it doesn't matter if you use a positive value of x or a negative value of x because you would get the same thing. So we have to make sure that we either put absolute value bars around the whole thing or write it as 2 times the absolute value of x. Again, the reason being is we can substitute in any negative or positive value into that x. So let's see if we make this a little bit nicer. Into this x right here, and it will give you the same thing. Just very similar to how we just worked through in these two problems up here. Now, I want you to take a second and see if you can simplify number 16 using the absolute value bars if necessary. Okay, underneath this radical, since you notice that we have the square root of a negative 7c being squared, we can also think of this as this square right here is going to cancel out with the index that we have, which leaves us with just this negative 7c. However, we know in order for it to be a square root, it has to be positive, so you either have to put the negative 7 inside the absolute values or take the absolute value of negative 7, which would be a positive 7. But again, we have to make sure we keep that c in the absolute value because it wouldn't matter if we used a negative or a positive value for the c here. Now we're going to be taking a step away from the square roots, and now we're going to be looking at the cube roots. Same idea, except for now we want to find a number that you multiply by itself 3 times. That'll give us another number. So following the same pattern that we looked at on the first page here, we want to think, okay, what number can we multiply by itself 3 times, which is going to give us a 27? And that's going to be the value of 3, because 3 times 3 is 9, times 3 is 27. So this answer would be a 3. Now, this next one, we have two pieces in it. We have a coefficient, and then we also have a variable part. So we have to look at it in kind of two parts, if you will, very similar to how we've been doing the previous ones. So we have the cubed root of a negative 27x cubed. So now we want to think of, okay, is there a number that we can multiply by itself 3 times that's going to give us a negative 27? And then what can we multiply by itself 3 times? That's going to give us an x cubed, and that's what we have to look at here. We know with square roots, we did not want negatives underneath because you couldn't square any negative value to get a positive. But here, though, we can use negative values because if we multiply a negative value by itself 3 times, we can get a negative. So here, if we take a negative 3 and multiply it by itself 3 times, we will get that negative 27. And then in the second part, what can we cube to get x cubed? And that would just simply be an x. So this one would simplify to a negative 3x. And what you can do is you can always check that. You say, okay, what if I take negative 3x times negative 3x times negative 3x? Do I get this right here? Do I get this radicand? And the answer here would be yes. So now what I want you to do, pause the video and look at number 19 and try that one out on your own. Okay, looking at this last one, first thing I marked is we bring down the negative out front first. Now I'm going to work through the radicand over to the right. So we have to think of something cubed that gives us a negative 64, which would be a negative 4. Something cubed that gives us y cubed would be y. So I'm going to take this negative 4y, and this is what I have in red right here. However, now we have a negative times a negative, which gives us a positive. So this expression right here would simplify to a positive 4y. Because we don't have to worry about the absolute value bars like we did in these examples here. So like we did in the examples over here with 15 and 16. You're moving on to the last page of the notes that we have here. What we're talking about now is even and odd roots. This is where you want to be very kind of careful with the negatives that we have. And also I'm going to show you how to type this in your calculator as well as I can using the app here. So the first one is we have the fifth root of 32. So we need to think, okay, what number can we multiply by itself 5 times? That's going to give us 32. Now, if you need help with this, we can use the calculator. I'm going to advance to the next slide here, which I have a calculator, and at least I can show you which buttons to press. Now, in our calculator, we're all familiar with how to type. Okay, going back to this. So what number can we multiply by itself 5 times will give us a 32? So again, we want to press 5, math, option 5, type 32 in your calculator if you don't know it, and you find an answer of 2. So the fifth root of 32 is 2. Now the next one, we have the fifth root of a negative 243. What you should ask yourself is, can I have a negative inside of this root? And here the answer is yes, because our index here is a negative number. Or I'm sorry, is our index is an odd number. If your index is odd, it's okay to have a negative inside of there because you're multiplying a negative number an odd number of times. So if it's an odd root, we say negatives inside are okay. So now if you need to use your calculator again, since the root is 5, type 5 on your calculator, the math button, option 5, and then negative 243, and you're finding this to give you a value of negative 3. Again, the idea is we want to know which value raised to the fifth power is giving us a negative 243. The next one, the fourth root of 1296. Here we think, okay, the fourth root, that is an even index. So that means we cannot have a negative inside of there because we have to multiply a number an even number of times, which would get rid of all the negatives. So to type this in our calculator, type 4, math, option 5, and type 1296, and that's going to give us an answer of 6. Again, the idea we're looking at is which number raised to the fourth power gives us 1296. Go ahead, take a moment, try the last one out. And you will see here, this one does not exist because we need to think of what number can we multiply by itself 4 times to give us a negative any one. Well, whenever this is an even number, we cannot have a negative, so it does not exist. Now what I'd like you to do is I want you to pause the video and I want you to try out all 7 of these problems here. You're going to be simplify, assume that no radicands were formed by using negative quantities to even powers. What this means is don't worry about using absolute value bars. Going to be working through assuming that no negative quantities were used. So go ahead, pause the video, work through these, and then come back and check your answers with mine. So you can take a moment and go through, you can pause the video again and check all your answers out here. There shouldn't be anything too terribly difficult or tricky. I have boxes around each of your answers. I tried to show a little bit of work that I could. Again, this is the kind of stuff I'd like to see on your homework. It at least shows me what you are doing and how you are working through these. If you have any questions on anything, please make sure you take a screenshot or write out, send me an email, whatever you need to do so you get your questions answered. Okay, the last thing we are looking at is number 31. It says a motorist is involved in an accident. A police officer measured the car's skid marks to be 245 feet long. Estimate the speed at which the motorist was traveling before braking using the function f of x equals the square root of 20x, where f of x is the speed of the car in miles per hour and x is the length of the skid marks in feet. Show work to support your answer. So we know that the skid marks are 245 feet long, and we say x is the length of the skid mark. So we need to substitute that. So we need to evaluate this function of 245. So we have to take the square root of 20 and then we have to multiply that by 245. Now when you take 20 times 245 in your calculator, we're getting 4,900. So we have the square root of 4,900. Now, easy way you can do this in your head is think, okay, well, what's the square root of 49? That would be 7. And then what's the square root of 100 would be 10. Put them together, or you can type it into your calculator. But we'll find that when we type the square root of 4,900 in, you get the value of 70. Now keep in mind, f of x represents the speed of the car. So that means that the car was traveling 70 miles per hour. Now, part B said if the posted speed limit is only 50 miles per hour and the motorist tells the officer he was not speeding, should the officer believe him? Well, and in this case, I would personally try to say no, because mathematically, if that's how long the skid marks are, he was traveling approximately 50 miles per hour. And 20 miles per hour is a pretty large difference between the two. I know this video is a little bit longer. If you have any questions on anything, please reach out. And good luck on the assignment. Have a good day. Bye. Square root, because you can simply just type second and then the x squared button to get the square root. However, that only works with square roots. If you need something like the cubed root or the fourth root or the fifth root, what you want to do, so for this problem using the fifth root of 32, there's a couple ways you can do it, but one way is to press the number 5 first, then hit the math button, and you'll see the options there of different kind of roots. And then I believe it's option 5 again will let you use the index of 5. It should have a little X on there on your calculator screen. And then when you hit enter, you should come up with a screen where you can then type the 32 and press enter. So again, you type the index, then the math button, and then option 5. If you need more help on that, you can always Google a video and it'll show you, or send me an email and I can walk you through it a little bit better.